Excuse.
Yeah, talk to me.
Do you have like any exact dates that you know you're gonna do like crash courses? Is it?
Say that again.
Do you know the dates that you're planning to do any crash courses? Well,
Oh
for my
yes. You saw the flyer with the math crash course?
no, so
No. Okay, okay. Let me just put it in the group chat. Put it in the group chat, or they could like share it up on thing. Get more out of the streets, kind of homeless.
right.
Yeah,
Sure, so thanks.
think stuff now. Think stuff. Wait, let me just share this thing. I will share it to you guys momentarily. Having two phones so cumbersome, man.
Yes, back. Sorry, my father. I did just call back to do something.
Oh, okay. What topic you need help in? Check
Some parts in circle geometry.
that. So I see that as a weak spot. Yeah, so that is the dates for the math crash course. The add maths crash course is I have the dates. I have tentative dates. All right. If you all are interested, just let me know to book your spot. Yeah, it's gonna be very, very intense. Those days gonna be like level jam, like real work. No sleep. Sleep is gonna be something you dream of. That kind of funny. Sleep is something you dream of.
I was not going to say something. I was not going to say that, sir.
Because if you don't sleep, you can't dream. Let's begin. All right, so who had problems with who was it? Alexia, was it you? Were you the one that had problems with pattern recognition?
Yeah.
All right, let me go, right? So get the question I read from her.
The diagram below shows the first four figures in a sequence of figures made up of squares of unit lengths. Figure 1, figure 2, well, yeah.
So let's see if there's a pattern, right? So how much squares do you have here?
3,
Have three over here. How much you seen over here?
1, 2, 1, 2, 3, 4, 5. 5.
How much you see in here?
7.
Seven. Are you all noticing a pattern of some sort? Three, five, seven. What do you think the next one gonna be?
Odd numbers.
9.
Yeah,
9.
these are these are odd numbers, but not yeah, they are odd numbers, right? They are n plus one. But more specifically, they just add in two. Everybody's seen that, right? 3579. These are odd numbers.
Yes, sir.
All right. So Alexia, if that's the case, how much do you think we have? How much squares do you think it'll have in this figure, which is figure five?
11.
Have 11, right? Cool. Let's go. You notice that it must maintain this pattern over here, but what's increasing is actually just this length over here. That's what that is what is increasing. You seeing that?
Yeah,
You're sure you're seeing that? So in all of
I think
them,
so.
you're seeing you're seeing this. Are you seeing that?
Mm-hmm. Yeah, the first three on top. Yeah.
Yes. So you had the first tree on top here, and then you add on to the bottom of that. Then you add in another set of two. And over here, you're adding another one. Seeing that?
Mm-hmm.
So you're seeing the pattern over here, the tree. So how much sets of twos do you think you're gonna have underneath that? So I'm gonna make sure you
Yeah,
how much?
I think 3. Wait, 2, wait.
Nah, it wouldn't be three. It wouldn't be three.
No. Wait, so I have to add one to this. So that'll be one set. So you're counting oh my lord. Are you counting the remaining one that I have here? Like right there? That do have the
This,
annex block, right? Yeah, that one.
yeah, we
Counting
counting.
that set?
Yeah, so how much other sets you need? Sets are 2. All right, so check this out, right? You see in this, you have that everywhere. And in this one, you have 3 sets of 2. So you have the same shape over here. So how much sets of 2 you need for figure 5?
4.
4. So let me just do that quickly. All right. Time I want to stop, right? I trust all you got right better any exam.
Yes, sir.
Yeah? Stop there?
Yeah.
All right. Is there anybody that didn't understand this at all? Like, are y'all seeing the pattern? Are y'all seeing that they're just adding 2 blocks every time the figure increases? Can we see that?
Yes, sir.
Yeah.
Okay, if you don't understand, I'll just let me know, right? Gary, let me know if you're confused by this.
Yes, sir. I understand.
Understand? Nikolai, Romano, Ariel,
Yes, sir.
Samir, Joshua,
Yes, sir.
me. Okay. And if we want to make sure we're correct, Alexia, what should these squares add up to? I say squares and brackets. Because it's not.
7.
Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You're okay with this, right?
Mhm.
All right, let's continue then. So don't worry about this. We could just jump straight to the table. They ask the same question every single time. I assure you it's the exact same question they're asking. So we have figure number here, represented by capital D. And Alexia, can't you see that we have different figures? Like you start off with 1, then 2, then 3, then 4, then 5, etc.
Yeah.
So n would represent that number. So over here, n would be equal to 1 because it is the first figure number. So n is equal to 1, n is equal to 2, n is equal to 3, etc. Now, over here, we have the number of squares. We have the number of sticks, and we have the perimeter. So let's see if we can see a pattern. So for number of squares, what are you doing? Are you noticing a pattern here?
Adding 2.
You're adding 2. You're adding 2 here, you're adding 2 over here, you're adding 2 over here. So in other words, you're repeatedly adding 2. And you seeing that? Like you're just repeatedly adding 2.
Yeah.
What do you call repetitive addition?
Multiplication.
Yeah. So you know what I'm going to do? I'm going to put out 2 over here. And the figure number is represented by n. So I'm going to put 2n. Now, the only question is, how am I going to satisfy, like, how am I going to get 3? How am I going to get 5, 7, and 9? So let me show you how we could figure that out. So, Alexia, when we have figure number 1, could you possibly tell me what n would be equal to? If the figure number is 1 here, what would n be equal to? Do you know?
3. I'm not sure.
Nah. So
Wait, 1?
in this,
No.
yes, because in this column, the figure number is represented by n, also capital D, but we're using n. So over here, for figure
Okay.
number 1, n would be equal to 1. What do you think it would be equal to over here?
2.
2. So you get the idea. And we've come up with this relationship over here so far, 2n. So when n is equal to 1, if we plug it into this, what are we going to get? What's 2 by 1?
2.
Okay, 2 by 1 is 2. Are we getting 3?
No.
Nah, but what we could do with 2 by 1 to get 3? Think to yourself.
Add 1.
Yeah, add 1. So, Alexia, we come up with something so far. So this is what we come up with so far. 2n plus 1. Now, for that to be true, it needs to work for all the other number of squares. So let's see if it works for the rest. Could you tell me what n would be equal to over here?
2.
N would be equal to 2. Let's see if our relationship works. So we came up with 2n plus 1. So anywhere I see n, I'm going to replace it with what?
2.
Exactly. And if all is well, what should I get for number of squares?
5.
I should get 5. Where's 2 by 2?
And plus 1 is 5.
Getting 5, right? Lastly,
Mhm.
let's check to see if it works for row 3. So when n is equal to 3, what number of squares should I get?
7.
Let's see if what our relationship works. So anywhere I see n, I'm going to replace n with what?
3.
Right? Do we get 7?
Yeah.
And maybe you still have trust issues for some reason. Do we get 9?
Mm-hmm.
Great. So I'll go over the process one more time. So let me start a roll call quickly. So Romano, Nikolai, Sky, Gary, Alexia, Christian, Vani, Mira, Joshua, Samir, Ariel. Can we all see that the number of squares is increasing by 2? Let me know if you're seeing that.
Yes, sir.
Yes, sir.
Okay, what do you call repeated addition? What operation is repeated addition?
Multiplication.
Multiplication. So this tells us that to get the number of squares, you are multiplying n by 2 because n is a figure number. N just represents a figure number. Over here, the figure number is 1. Here's 2, here's 3, etc. So we're seeing repeated addition, which means multiplication. Hence, I wrote 2 by n. Now, what was the next thing I did, Nikolai? Could you tell me the next thing I did?
Yeah.
So far we have
Repeat the
2n.
question, sir.
So
Oh.
far I have 2n. But that's not entirely correct because when n is equal to 1, if I use that formula, I'm going to get 2 by 1. But what am I supposed to get when n is 1? What am I supposed to get?
You're supposed to get 3.
So what would I need to do with 2 by 1 to get 3?
Yeah, add 1.
Right, I add 1. And so my test relationship is it becomes 2n plus 1. I'm multiplying the figure number by 2 and I'm adding 1 to it. Now, it mustn't just work for one case. For the relationship to hold, it should work for all values of n. Understand?
Yes, sir.
So what would happen when n is equal to 2? Let me ask somebody else. Vani, when n is equal to 2, how much number of squares should I get? Tell me, Vani, when n is equal to 2, what number of squares should I get?
2.
Nah, Vani, look at the table and tell me, when n is 2, how much number of squares should I have? What number of squares should I have?
1.
Nah. All right, so Vani, here, we're gonna run through this one more time. I gotta make sure you understand this. Vani, this is easy marks, you know. I trust me. 3, 4, 5. This is easy. I don't want you to lose these marks, Vani. So, Vani, all these questions come the exact same, right? You have the first column, and the first column represents n, where n is just the figure number. So, Vani, n is equal to 1 here, n is equal to 2 here, etc., etc. You understand that part?
Yes, sir.
All right. Then we have a column that says number of squares. So, Vani, when the figure number is 1, what is the number of squares?
3.
3. When the figure number is 2, what is the number of squares supposed to be?
5.
Great. When the figure number is 3, what is the number of squares supposed to be?
7.
Great. Are you seeing a relationship between 3, 5, 7, and 9?
Yeah.
Right. We are repeatedly adding what?
2.
What do you call repeated addition?
Multiplication.
Right. So we could start off our relationship by doing this. N represents the figure number. And so you're multiplying n by 2 because you know this is repeated addition. Now, this is only half the story, Vani. If I use it as is, there's a problem. Let me show you what the problem is, Vani. So, Vani, when the figure number is 1, what am I supposed to get? I promise I'm not tricking you here. Tell me, Vani, when the figure number is 1, what am I supposed to get for the number of squares?
3.
Supposed to get 3, right? If I use this relationship I came up with, then it'll be 2 by 1. Will I get 3?
No.
What would I need to do with 2 by 1 to get 3?
Add 1.
Okay, so our relationship now becomes 2n what?
Plus 1.
Okay, now you can't just call it a day, right? You need to check it for other figure numbers. So Vani, when the figure number is 2, how much number of squares should I have?
5.
I should have 5. And so let's see if that would work. 2 by 2 plus 1, does that give me 5?
Yes, sir.
Right, so my relationship has been verified. It's 2n plus 1. Is there anybody that doesn't understand how I did that? How I came up with that?
At first, I didn't understand. Now I do so.
Okay, nice. Don't worry, Nicola, you're doing a lot now. We're going to do a bunch of these questions. After today, you should definitely be getting these 7 marks. Christian, are you confused? If you are, just talk to me, let me know. Can I hear him, Christian? Romano, Sky, Gary, Alexia, Ariel, Mira. Just let me know, guys. Let me know what's going on. Are you all confused?
No, sir.
No,
No.
sir.
No, sir.
Okay.
No, sir.
All right. So Alexia, let's just fill out the rest. So Alexia, when the figure number is 5,
Mm-hmm.
how much squares should I have?
11.
And we figured that out, right? That was in the diagram above.
Mhm.
No problem. Next thing we should probably do. Let's see if we could come up with a relationship for a number of sticks. Let me call upon somebody else for this. So Joshua, for the number of sticks, are you seeing a relationship?
Yes, sir.
What are we
Plus
doing?
5.
Right. And Joshua, if we keep adding 5,
30.
right, you'll get 30. Is everybody seeing that? I'm just adding 5.
Yes,
Yes,
sir.
sir.
What do you call repeated addition again?
Multiplication.
Right. So Joshua, I'm going to write 5 times what in the relationship over here? I'm going to write 5 times what?
5 times.
Right. So 5 times the figure number. So Joshua, 5 times n. That's what I'm going to put, 5n. But Joshua, this isn't entirely correct, huh? This is not entirely correct. So Joshua, let me show you how to figure out how to complete this. So Joshua, what figure number gives us 10 sticks?
10 what? 10 6? You see?
Let me say that again. Which figure number gives us 10 sticks?
Oh, 10 sticks?
Yeah,
1.
1, right? Cool. That's good. You see that, right? So Joshua, when n is equal to 1, this is all we're gonna do. We're gonna plug it into our relationship so far and see if it gives us 10. So Joshua, we came up with 5 times n, and we're looking at when n is equal to 1. So that's gonna be 5 by 1. But Joshua, do we get 10?
No.
No. What would I need to do with 5 by 1 to get 10?
5 multiplied by 2?
Nah. You're not wrong, but these questions, you always add on something. So 5 by 1 plus what would give you 10? See if you can figure that out, Joshua. So 5 by 1 plus what would give you 10? All right, so Joshua, what's 5 by 1?
5,
5 plus what would give you 10?
5,
All right. So Joshua, if 5 by 1 plus 5 gives me 10, then that's good. So we need to write what our relationship is now. So Joshua, we started off with 5n, but to get the 10, what did we add on? Tell me.
we add on the 5
Right.
because
Because
since that there was already 5 by 1 equals to 5 and then plus 5 equals to 10.
right. So Joshua, our relationship now becomes 5n, what? 5n. So we started off with 5n, but when we used that formula, we didn't get 10.
5 and plus 5?
Yes. But we need to make sure that's correct. So Joshua, let's verify it for some other figure numbers. So Joshua, when n is equal to 2, how much sticks should I have? Tell me, Joshua, when n is equal to 2, how much sticks should I have?
15,
Right, let's test our relationship. So I'm going to put 5 multiplied by
5 multiplied by 2 plus 5?
5 by 2 is
10, 10 plus 5 is 15.
nice. And you know what? We could test it for one more. So when n is equal to 3,
5 by 3 equals to 15, and 15 plus 5 equals to 30.
right. So could I go ahead and write 5n plus 5 for my relationship?
Yes.
Great. Alexia, anything confusing you at all?
No.
All right, so Alexia, let me just wrap it up. Let me make sure you understand this thing once and for all. So Alexia, are you noticing a
Mhm.
relationship for the last column, perimeter?
Multiply. Is it multiplied by 2?
I'll be adding 2, yeah. So you'll multiply what by 2?
By the figure number. So
So how would I write that?
n wait. One, and I think I know how to like work it out, but I don't know how to write it.
Right. Let's look at the previous examples, right? So Alexia, for number of squares, the common we saw that it was repeatedly adding 2. So that
Mm-hmm.
right. If you're repeatedly adding 2, then that's multiplication because you keep adding 2.
Yeah.
So what did I multiply by 2?
2. 2n.
Right. So what do you think I'm going to write here?
2n plus 2.
Now, we need to verify that. You can't just say that. So let's verify to see if it's correct now. It's only now we'll see. So Alexia, when n is equal to 1, wait, I'll have to put it somewhere over here. Yeah, so Alexia, when n is equal to 1, what should the perimeter be?
8.
It should be 8, right? Now, if I put 2 by 1, what am I going to get?
2.
Do I get 8?
No.
Nah. So what should I add to get 8?
4.
Nah. 2 plus 4 is 6.
Oh no, 6, my bad.
All right. So our relationship then becomes 2n, what?
Plus 6?
Now let's verify that again, right? So we get the 8 over here. Great. When n is equal to 2, what should I get for the perimeter?
10.
So if n is 2, I'll write what instead? All right.
2?
And we said plus 6, right? Would that give me 10?
Yeah.
Yeah. So is this relationship valid?
Yeah.
Yeah. So here what? Let's run through the process one more time just to make sure all of us understand this. So Alexia, it will be repeated addition. If it is repeated addition, like let's look at the second column. You are repeatedly adding 2. If you're repeatedly adding 2, we could say 2n. The next thing you'll have to do is you'll have to figure out what we would have to add to that to get 3. So Alexia, if we just said 2n and you put n is 1 into that, you're gonna get what?
2.
But we want to get 3, right?
Mm-hmm.
So what would you need to add to that to get 3?
1.
Yeah. And then you just check it for the rest. And that's how you figure out your formula. You genuinely think you understand this? Or nah?
Yeah.
You see, you're not a little unsure, and it's scaring me.
No, I am understanding.
Okay. What about the rest of you guys? And don't get me no like I understand it just cause like if you don't understand, just tell me straight up. I will go over it. Yeah, tell me.
No, sir, I understand, sir. At first, I was so confused as to how I was to get the n to add up to the other numbers, but now that you show that, it's looking a lot easier to do so.
Well, we go see, right? When I give all that question, we go see. We go
Yeah.
see. All right. Let me do a quick roll call. Ariel, Samir, Joshua, Mira, Vani, Christian. How are you feeling? Ariel, Samir, Joshua, Mira, Vani.
Positive about this
Good,
question.
good, sir.
Good, sir.
I understand it.
All right.
understand.
Romano, how are you feeling?
You cooking?
All right. Gary, how are we feeling?
Yes, sir. I'm feeling good.
Okay. So, Alexia, I want you. So I'm going to erase this, right? I'm going to erase this. And your job now is to teach me and the class.
Oh Lord.
You gotta tell us how to find this. This is good. This is a good opportunity to learn. Because if you don't know something, you'll see that you don't know it. So tell us, what's the first thing? What's the first thing we should
Well, the first thing you're supposed to do is figure out the pattern of the number of squares. And if we look at the number of squares, we see it's increasing by 2 because 3 to 5 is you add 2, then 5 to 7 you add 2, and 7 to 9 you add 2. So it's increasing by 2. So they want to figure out the number down below. And in order to figure out the number down below, we see that we call it n, which represents d, which is the figure number. The figure number is the ones on the first column, which is the ones increased, which is 1, 2, 3, 4, 5, 6, right? So we're calling that n because they want to find out what n is. Well, the line, the fill in the blank. So in order to figure out what n is, we put in n by the figure number.
wait, I had to correct you. We're not trying to find for n, you know. What we're trying to do, we're trying to figure out a relationship for number of squares in terms of n. That's what we're
Okay,
trying.
yeah.
So like we're not trying to find n, you know. We know what n is. N is 1, n is 2, n is 3. We're not trying to find for n. We are trying to find a relationship that tells us how this n and the number of squares are linked together. So let me put that in simple words here. We're finding a relationship for number of squares in terms of figure number. number of squares in
Um,
terms of figure number.
but in finding number of squares in terms of the figure number, what we have to do is take the figure number, multiply it by itself by 1, and then add 2 to it. So it said if we the is to be 2 by 1, which is the figure number, plus 1, which is 3.
Wait, let me just
And
good
after,
notes being real
you
stupid.
just not,
Yeah.
yeah,
So continue.
okay. And after, in order to do that, we do it, repeating it consistently. So it'll be 2 by the figure number, and the figure number is 2. So 2 by 2 is 4, plus 2, because we figure out it's increasing by 2. No,
Wait,
2
nah,
by 2 is 4, plus 1, which is 5.
right.
My bad. So, so we're going to do the same thing, and
Yeah.
it's always consistently increasing by 1 once you're multiplying it by itself. So
Right.
it'll be 3 by 3, which is 6, plus 7, plus 1, which is 7, and 4 by 4 is 8, plus 1, which is 9. So
Right.
after once you figure out, down below, it will be 2n plus 1, and that is how we find 2n plus 1.
That wasn't so bad. Seems like you understand it. Let me call upon somebody else. All right. So Mira. Mira, I like to call you. Yeah. So Mira,
Hi, hello.
explain to me in class. How did we get 5n plus 5
Okay,
for the number of
so
6?
so we look at the number of stickers, and then we could see that there's a pattern going on. So 10 plus 5 is 15, plus 5, 20, plus 5, 25, and plus 5, 30. And then to figure out if the answer is actually correct, as in plus 5, the same exact thing that, well, I would say formula that you use to find number of sequins, you're using that to find the number of stickers. So 5n is plus 5 plus
How you know it's plus 5? Like, where that plus 5 come from? How you know it's plus 5?
10 plus 5, 15.
So we have to test it with the values in the table to make
Yeah,
right. Okay.
so the first one, n1, which is number of figures. Figure number 1, right, would be 5 by 1 plus 5. 1 5 is 5 plus 1 plus 1 5 is 5 plus 5 10.
Right. And then just check it for the rest.
And then you follow along. Yeah.
Nice. I will see if you all don't understand quickly when I give you all when I give you all a question. So let's proceed. Alexia. Now you'd notice that we have some missing values over here and over here. Now you realize that this 47, that doesn't come after the 11, right? That's actually somewhere, that's like a good bit past the 11, you see in that?
Mm-hmm.
So
I get 23.
20, let's see if that's correct. So how are you going to do this? Well, remember Alexia.
I
Oh,
work backwards.
so this formula over here tells us what number of squares is in terms of what? Tell me, Alexia.
Repeat, please.
This formula tells us what the number of squares is in terms of what? What's the variable there for this? What's the variable in this?
The figure number.
Yeah, n. N is the variable, right? So this
Mm-hmm.
formula tells us what the number of squares is in terms of the figure number n. Now, if that is the case, then we could form an equation. Because the number of squares here is 47, right? And that's supposed to be equal to 2n plus 1. So we could write 2n plus 1, and we could put that equal to 47. And from there, you just solve for n. So how would I solve for n?
Well, you subtract 1 and have to divide by 2.
Perfect. So I'll move across that 1, and that would turn to 47 minus 1. And that's going to give you 46. You want to find for 1n, so you divide both sides by 2. And yeah, you get 23. All right. So, Christian, I want you to help me figure out what's coming here. See if you can help me with that, Christian. Christian, let me know if you're there. Okay, I'm not hearing from Christian, so I'm gonna call upon Romano. Romano, you think you could help me figure out what's going here? Yeah, what's going here?
Alright, well, we know that the figure number for that perimeter is 23.
Mm-hmm.
So we have to apply that in the thing 2n plus 6.
Perfect. So that'll be 2 by 23.
2 by 23 plus 6.
That
So
should
that'll be
40.
46 plus 6. Is 52.
Yeah. Guys, do we understand this? If you don't, now
Yes,
it's
sir.
summer. All right, Gary, did you understand everything we do here?
Yes, sir.
Okay, good. So let me show you how much marks you can get for this, right? So this is 7 marks over here. 7. This so far is 9 marks. And well, this is 10. It's gonna make it 10. All right. So Sky, I want you to read part C for me.
Marla says that she can make one of the figures with exactly 502 squares. Explain why she is incorrect.
All right, so Sky, let me hear how you would do this.
Um, so I'm not sure. And also have to understand, how do 1 part 2 and part 3 can be.
Wait, just to clarify, you understand part 1, part 2, and part 3, or you want me to go it over?
So you could go on for part 3, please. Yeah. No,
Okay.
not part 3, part 2.
No problem. In the meantime, guys, you all could try to figure out part C. So Sky, in part 2, notice that, wait, let me just erase it. We'll figure it out from scratch. So Sky, you okay with how we came up with the relationship?
Yes.
Yeah, sure.
Mm, yes, I think so.
Here what, Sky? Here what? We do the next question together, right? We do the next question together. The next pattern recognition question. But let me continue. So Sky, this formula over here tells us the number of squares if we put in the figure number. Let me explain that one more time, Sky. So the figure number here is 1, here's 2, here's 3, etc. You understand that this is the figure number n? I'm gonna know.
Yes.
Right. So if I take the figure number and I put it into this, what should I get? What should I get, Sky?
So you can repeat that.
If I take the figure number and I put it into this formula, what am I finding for?
What you're trying to find, the number of squares.
Perfect. So this formula tells us how we could find the number of squares using what?
Formula.
Using n.
Well, and
Because in this formula, what's the variable?
n.
Yeah, because you're changing n, right? N is varying. So let's try to understand that one more time. So Sky, this formula over here, it tells us how to get the number of
Squares.
using the
variable.
So like what am I putting in into that to get the number of squares?
So you're lost now. What's your words right now?
All right. So what is n? Remind me, what is n?
The figure number.
Right. So you're finding the number of squares using the
Figure number.
yes. So
Okay.
when n is 1, how could I use this formula to find number of squares? See if you get some of that, Sky. So when n is 1, how could I use this formula to figure this out?
So not 2n plus 1.
Right. And if the figure number is 1, what would n be equal to?
1.
Yep, n would be equal to 1. So anywhere I see n over here, what would I write instead?
1.
And if we are correct, how much number of squares should I get?
3.
Do we get 3? What's 2 by 1 plus 1?
3.
Right. Let's see if it works for, say, n is equal to 4. So tell me, Sky, when the figure number is 4, how much squares should I have?
9.
Let's see if the formula we came up with works. So what am I going to input into the formula here? What am I going to put into that formula to find the number of squares?
So 4n plus 1.
2 by 4 plus 1. And do we get the correct answer? Let's see. What's 2 by 4?
2 by 4 is 8. 7 plus 1 is 9.
Right. So do you understand that the formula we came up with here tells us how we can get the number of squares if we put in the figure number?
Yes, sir.
All right, nice. And so over here, you know what the number of squares are, but do we know the figure number?
No, sir.
Nah. Do we know the relationship linking n to number of squares? Do we know how they are linked together? Thomas Guy.
For me personally, I don't know.
All right, 2n plus 1. That's the relationship. Remember, Sky, this 2n
Okay.
plus 1, it tells us how to figure out number of squares given what?
Figure number.
Right. So this relationship here, it links the figure number to the number of squares. So how could we use that to find for the figure number d? Well, if you look at this, 2n plus 1 is equal to what? I'm trying to go over that again, right? So this formula here, it links the figure number to the number of squares. That's what it does. Do we know what the number of squares are?
47.
Right. So in other words, 2n plus 1 is supposed to give me what?
47.
Right. So now we are trying to find the value for n that would give me 47. Can you think of any number you can multiply 2 by? I mean, can you think of any number you can multiply by 2 and then add 1 to get 47?
Number you multiply by 2 and add 1.
To get 47. Here what? Let me do the algebra, right? And you will see the answer. So how would I work this out? What do I solve for n? Talk to me. How would I solve for n?
So you put 47 on the other side and put n
Nah,
equal to n.
if you're trying to find for n, you want n to be the only thing on that side. Could you tell me what is the n term on this side?
So
2n, right? 2n is the n term on that side. So I have to leave the n term over there. And you're going to take the numbers and you're going to move it across to the other side. So we have +1 over here. It should not be over there because we want n to be the subject of the formula. So we're going to take the +1, we're going to move it across. Another way to think about it is you're taking away 1 on both sides. So 2n is going to be equal to 47 what?
-1.
Right? So what are you going to get?
So n equals 46.
Right? And you have 2 times n. You want to find for 1 n. So what you have to do on both sides?
Multiply by 2.
Nah.
Oh, no, multiply by 48, sorry.
Nah. You want to find for 1 n, you want to find for n. Right now I'm multiplying n by 2. What would I need to do to find for 1 n? I want to cancel off the 2. What would I need to cancel off the 2? What do I need to do?
Not divided by 2.
Yeah, I'll divide it by 2.
Excuse me, may I use the washroom?
Sure. Yeah.
Thank you.
You don't ask me how to use the washroom, but for sure. Yeah. And 46 over 2. What is 46 over 2? Tell me, Sky. 46 over 2 is?
23, sorry, sir.
Right. So that's my answer. And it makes sense because, Sky, when n is 23 and I plug it into this, what am I supposed to get?
The number of squares.
Which is?
47.
Yes. What's 2 by 23?
So is it no, not 45, 46?
Right? And what is 46 plus 1?
47.
Yeah.
It makes sense.
Right. And over here, we're trying to figure out the perimeter. As we're trying to figure out the perimeter. Do we have a formula for the perimeter?
2n plus 6.
Right. You think you could tell me what this formula does?
You're using the figure number to find out the parameter.
Yes. Yes. Do we know what the figure number is for this column? I mean for that row?
No,
Nah, we do. What is the figure number?
wait, 23?
Right, 23.
Oh,
So what am I gonna do with that 23 now to find the perimeter?
so I don't know, no mind telling me to go back the same thing you did to find the figure number on the other side.
Wait, just tell me whatever I have in mind. If it's wrong, at least we go learn from it. But just tell me whatever I have in mind.
Okay, so just now.
All right, so Sky, this formula over here, it links the perimeter to what? Remind me again?
The figure number,
Right. Do we know what the figure number is?
23.
So what should we do now to find the perimeter? I promise it more obvious than you think. Get real simple. I promise.
So I was gonna say substitute the figure number into the
Yeah, that's what you had to do. That's what
two
you had.
by 23 plus 6.
Yeah, because that formula it gives you the perimeter if you have the figure number and you have the figure number is 23. So that'll be 2 by 23 plus 6 and you'll get 52. Yeah.
Okay. I understand this one better than the first one.
And well, all the questions follow this exact same format. Right? So let me answer part C now. So Mala says that she can make one of the figures with exactly 502 squares. So we're talking about squares here. Immediately, what formula should come to mind here? They're talking about what of squares? Thomas Sky, they're talking about what of squares?
Figure.
Hey, Samir, just come for your mock exam.
Yes, sir.
You get it correct?
Yep.
Okay, cool. Yeah, so Sky, you're seeing 502 squares. So we're talking about what there? Figure number, perimeter. We're talking about there.
Figure number.
Nah.
Because that seems to me like the number squares, but
Yeah, it's number of squares. It's number of squares. Because
they make me feel like you're like I already kind
what
of
hey,
saying that right now.
you you know how to judge it, thing? You just tell me whatever. You tell me whatever you think is correct.
Okay. So number squares.
Exactly, because you have 502 squares, so you have that number of squares, right?
Okay.
I tell you, math's more obvious than you think. Like, maths is highly logical. Unless you're doing them worded problems that can are real long and annoying. So we're looking at number of squares here. Could you remind me what the formula for number of squares is?
2n plus 1.
2n plus 1. And she said that she could make a figure with how much squares?
502.
Okay. Now I have a question. The figure numbers. Do you think the figure numbers could be fractions? Or do you think they have to be whole numbers?
So can they be fractions?
Asking you that. Check it out. You think we could have figure 1.5?
Oh, so that figure 1.5 is not like four blocks. Like the 301 on the bottom.
It don't have no such thing as
Okay.
we maintaining a specific pattern over here. So you can't interpolate, you can't really the figure numbers, it just have like the figure numbers are whole numbers.
Okay, so
You can't have fractional numbers for that. And that's exactly why she is incorrect. You'll see. So we have the formula for number of squares here. It's 2n plus 1. So the number of squares is 2n plus 1. And how much squares did she say how much squares she say she could use? I mean,
I
I
would,
502, right? So do
yeah.
you understand that this formula here represents the number of squares?
So I didn't hear what you just saying.
Do you understand that this formula over here represents number of squares?
Yes, sir.
And this formula over here tells you the amount of squares she wants to make.
Yeah.
All right. So I'll put them equal together. And now I'm going to solve for what?
The figure number.
Exactly. The figure number needs to be a what?
A whole number.
Exactly. So if you get a number that is not a whole number, then that's incorrect. So let's solve this. So how would I solve n?
I will solve for n.
Mhm.
Substitute.
Nah, you don't have anything to substitute. You don't know what you're trying to find the value for n. You can't substitute. Because if you substitute, that means you know what n is. But we don't know what n is. So Sky, we have to n, if you're trying to find for n needs to be the only thing on the left hand side. So what is the n term on the left hand side? Tell me, what's the n term over here?
On the left hand side.
Yeah,
2n
2n, right? So it belongs there. What shouldn't be here?
plus 1. So you move plus 1 to the other side. So it's 502 minus 1, which would be 501.
What next?
You divide 2n equals 501 by 2. That's still not supposed to be there.
Are we gonna get for n?
Um, okay, so I get 250.5.
Ah, guys. Could we have a decimal or a fraction of our figure?
No, sir.
Nah. So you would say Mala is incorrect. Because try to figure out a nice sentence right here. Mala is incorrect because n needs to be an element of whole numbers. There cannot be, wait, there cannot be a fraction of a figure. We okay with that question?
Yes, sir.
All right.
Yes, sir.
Yes,
All right.
sir.
Let's just do a quick recap. Does everybody understand how to come up with the formula linking the value with the figure number?
Yes, sir.
If you don't,
Yes, sir.
tell me.
Yeah.
Right. The other types of questions will involve you finding for the figure number. So you'll have to make an equation and solve. And then you'll have to plug it in to find for a specific value. In this case, what did we find for? After finding for the 23, we plugged it into this formula we had for perimeter to find the perimeter. That's typically how the questions go. Let's do June 2025 now. Wait. Okay, let's go. So, Alexia, are you feeling like you understand this thing a bit more? Alexia, let me know if you're there.
I hear me.
Yes, let me know if you understand this thing a little more.
I said yes, definitely.
Well, let me see if you could lock in and get us one correct in one go, right? So you're gonna
Okay.
help me with this one, and Sky, you're gonna help me with this one. Before we do that though, okay, well, I completed the diagram because I do this paper before, but look at the pattern and see if you can see it for yourself. Let me know if all you're seeing it for yourself. Are you guys seeing the pattern or not?
Yes, sir. Yes, sir. Yes, sir.
So like, Nikolai, what are we doing? Well, every figure, I'm adding another another pentagon. You see in that? We had one pentagon here, we have two, and we have three. Yeah.
Sir.
We start off with one, we add one over here, then I add one over here. So notice like it kind of alternating, like one on top, one on the bottom here, one. Okay, so top, bottom, top. You can kind of see, you see what I'm talking about or not?
Yes, sir. I was just
Yeah.
noticing that the 6 doesn't add up. Like the first one was 5, then this one is 5 plus 3.
It will be different. It will be different. It will be different.
Yes, sir. Okay.
Now if you forget the dots, you will not get full marks. You need to put the dots. But just confirming, now you all see in the pattern, everybody, Romano, Sky,
Yes, sir.
Alexia, Ariel, Samir. Let me know, are you all seen it? Mira.
Yes.
Yeah, sir.
All right. Let's continue. So Alexia, you know how to do this now, right? I trust that you know how. I know you know how to do it. So tell me, what pattern you see in here between the number 6
And then 4.
and 4? So what am I gonna write here one time?
Where? Oh, and
We typically write the number in front. So like, I wouldn't say
oh,
x5. I'll say like 5x. You know what I mean?
yeah, I know that. 4n
Mm-hmm. Right. So we
plus
add in 4 repeatedly.
plus
Right.
1.
Now let's see if that is correct. Now when n is equal to 1, I'll put 4 by 1, but I get 4. But I'm supposed to get what? What am I supposed to get?
5. So you add 1.
Perfect. So it now becomes 4n plus 1. Now to verify that this works, we'll do it with another figure number. And so this is going to be 4 by 2. That gives me 8. But you know what I want? I want 9. So again, I must add 1. So we get our relationship, 4n plus 1. Do you fully understand that?
Yeah.
Lovely. Sky, help me figure out the number of dots.
Um, 3n plus 1.
3n plus 1. Let's see if that's correct. So, Sky, when the figure number is 1, how much dots am I supposed to get?
5.
Supposed to get 5, right? If I plug it into this formula we came up with, that's going to be 3 by what?
3 by 5.
Nah,
Or 3 by 1.
3 by 1. Because it's 3n plus 1. And remember, figure number is n.
Okay.
And I said
I don't,
plus.
I don't think it will add up.
Nah. So here where you're supposed. I feel like I say plus 1 because Alexia
Yeah,
plus
I
1.
think I think I'm supposed to say plus 2.
That sound more like it. So
Mm-hmm.
here was the process. You see, now you keep on adding on 3, right? Automatically
Yes.
3n. So then we're gonna test that. So when n is equal to 1, I am supposed to get 5. So I'm going to put 3 by 1. Notice I get 3. 3 plus what would give me 5?
2.
2, right? Right, then I check that again. When n is equal to 2, I'm going to put 3 by what? Thomas Sky. 3 by?
3 by 1.
Why 3 by 1?
So you know, put the same thing as in the first one.
No. Because is the figure number remaining the same?
No, it's changing. Okay, so 3 by 2
What are you supposed to get? When the
six
figure number is when the
is
I'm supposed to get?
6 plus 2 is 8.
Right. I need to add 2 because I'm supposed to get 8 when the figure number is 2. So my
Okay,
relationship,
I got
okay,
you now.
do the last one for me. Explain the last one for me.
So and it's supposed to be equals to 3. So then it's 3 by 3, which is 9, plus 2 is supposed to be 11.
Right. So the pattern now becomes 3 and what?
Plus 2.
Yep, 3n plus 2. Because you have 3n, right? That's one thing, but to get the final answer, you need to add 2. Yeah. You fully understand this?
Hopefully.
All right. So I'm gonna call upon Mira now. Mira, how would I fill out the number of sticks over here?
So you know that the number figure is 20.
You see, like a guy, and he's just now number figure. Yeah,
Figure, oh my god.
it's happened. It's happened.
It's like the working boss of short roti, they say clap roti.
That's never mind. Yeah, so we go say 4 by what?
4 by 20
Mm-hmm.
plus 4.
You gotta explain to me where you get the plus 4 from.
Like, so the number of sticks, right, is in a pattern where we're adding 4 basically. So 5 plus 4 is 9, and 9 plus 4 is 13.
Wait. But that is not what we're doing, you know. What
Oh, wait.
we trying to figure out, we came up with a relationship linking
Yeah,
the number of sticks to what?
the number,
So we found a relationship linking the number of sticks to the number what? To what?
to the figure.
Yes. That's what this is. So tell me. Yes, we'll continue.
Plus 1.
Yes. Because Sky, do you understand that this formula, it tells us the number of sticks when we put in the figure number.
Yes, sir.
All right, cool. And with 4 by 20 plus 1 is what, Mira?
90. Huh? Wait, what? 80 plus 1, 81.
Right. Okay. Sky, could you help me figure out this?
Okay.
Sky?
Yes, sir.
Yeah, I promise.
I'm kind
It's
I'm kind of confused
what confusing you?
because honestly, I don't know how Mira just do what she do.
All right. So, Sky, let me erase that, right? Sky, what's the purpose of this formula over here? Talk to me. What's the purpose of that formula?
To determine the number 6.
Using what?
the figure number.
Right. So you figure this out for me. I believe you could figure it out. So okay, wait. Let's go like a real basic. How would I figure out the number of sticks when the figure number is 1? Sky?
So 4 by 1 plus 1.
And that would give you 5.
Right.
How would you figure it out if the figure number is 3?
4 by 3 plus 1.
Okay, how would you find the number of sticks if the figure number is 20?
Or 4 by 20 plus 1.
Yep.
Okay.
How would you find the number of dots when the figure number is 20?
3 by 20 plus 1 plus 2.
Yep,
Okay.
that is it. I tell you, it was simpler than you think, you know.
So what you said?
I tell you, it was simpler than you think.
I
Simple.
don't know what's going on with my brain right now.
Need to eat a roti from Mira shop. That will fix it.
Telling you.
Yeah. All right. So, Sky, you think you could figure out what the figure number here is? Over here.
Okay, so wait, total math just now. 4 by 169 plus 1.
Nah. Is 169N? Yeah, that's up there.
No, okay, no.
Does 169 represent the number N? I mean,
No.
nah, it doesn't. It represents what?
The number 6.
Right, that represents the number 6.
Okay, so I don't know.
No, you can figure this out. It's the exact same thing as the last question. Exact same thing. No difference. Here,
As the one that we just did.
I want you to
Or the
explain.
one before.
I want you to explain to me. How did we get 23 over here?
Okay, so oh, okay, I see something there. All right. Okay, so go back. I think I get. I think I get.
Here.
So don't laugh at me. Hey, you're laughing at me.
I would never laugh at you.
So we put in 4n plus 1 equals to 169.
Why did you think that was wrong? That's correct. Because you are trying to figure out the value for N that makes this equal to what?
169.
Right. Because this formula tells us the number of sticks when we put in N. So you're trying to find the value for N that would give you 169. You understand or not?
Yeah.
Right. So what next? What we gotta do?
So we had to move whatever that not supposed to be on the left hand side, which is plus 169 minus 168. And then divided 4n equals 168 over 4. Well, by 4. So that's supposed to be 42. So then equals to 42.
And how could you check if your answer is correct? Let me see you think.
Okay, wait. 4 by 42 plus 1.
Yep. Check it for me. See if you're getting back 169.
Right. Because 42 by 4 is 168 plus 1 is 169. Okay.
You can understand anything now.
So you see, when it's like a funny spot, like my brain will just go blank and I just can't remember anything.
How
But
does
when
all you know about what you know? All you know about that?
so
All you know about the TikTok series and it is be on YouTube too. What you know? All you know about that?
Oh,
oh
yeah.
yeah, but you know.
Yeah,
You know, he was actually, my mother actually see him the other day in Gasper.
I feel like I might be a little scared to see all you go on that show. A little bit. Because not everybody is very not everybody is like non-judgmental now. Like if you go on that show, you might say some things that people go clung you for.
Actually, sir, I don't think we'll be that bad as to what we see the people in the show, sir.
Mm,
Like, we could get the answers, but not all of them. Some of them don't get the answers at all. So,
I see this man ask somebody what would be 25 minutes past 9:45. Oh, you know the answer, right?
I
25.
think it was 9:40, and then he said 10:05. What was the time in between that? And the man couldn't answer.
Oh, yeah. Now, Ollie's saying that Ollie wouldn't get caught, right? But when you're under the pressure, you go say some things, like you just can't think. You'll be like Sky. Sky
Actually,
said,
I never said that. I said we could get some, not all.
So what boost me, sir, is how he used to give people 1,000 and things. That would boost me, so I'm
oh,
like, forget this.
well, we had Gary Griffith in class.
Mm.
Hey, Gary, I feel like you're scaring Sky, I feel like you're scaring she. She kind of
Nah, don't
Oh,
even, don't even.
Gary Griffith. She's scared of Gary Griffith for some reason. Yeah. Sky, you didn't do anything illegal, right?
No, sir, no. Mm-mm.
Okay. All right. So Sky, I want you to figure out now the number of dots.
Right. Okay. I had to boost myself because so you try to distract me, you figure out I was just talking about. Okay. Um, we know the figure number. So then, so now 3 by 42 plus 2.
No, I wouldn't be any example to tell you if what correct or what wrong, right? You tell me you think that correct. I need you to tell me if you think that correct. Honestly, like forget about what anybody's saying or what anybody think. Do you think that's correct? Logically, like don't let me make it bias towards yes or no. You just tell me honestly, you think that's correct?
Yes, sir.
Good.
And I would answer as 128.
That's correct. Because I wouldn't be any exam to tell you, hey, that wrong, that right. You know?
So the fact that that is the first thing that comes to my mind. That, well,
So
no.
3 by 42 is 126. I think you should get 128. I think. Uh check that for me.
Yes, sir.
All right. So, Alexia, you're getting the 7 marks in the exam. Well, it's not 7 marks here, but I don't know.
Yeah,
It was easy or hard.
it was easy.
So I see it. It look. I can't even say it looked that. the follow-up questions is be kind of scary. Like for instance, Alexia, read part C for me. It kind of scary, not gonna lie. Read part C.
Write an equation in S, D, and N to show the relation between the sticks S and the number of dots D for the figure N.
Yeah, it's a scary question. So they want us to write an equation in terms of S, D, and N to show the relationship between the number of sticks and the number of dots. That's what they want you to do. Right, so the number of sticks and the number of dots. Right. Okay, so this is what I mean. Like these and it's a 2 marks. So I would say this is a harder question than any of these questions here. But we're gonna break it down and you're gonna see it's not as hard as you think. So Alexia, the number of sticks and the number of dots. So Alexia, do you notice any relationship between the number of sticks and number of dots? We need to look for a pattern. We need to look for a pattern.
As in like as in part 3, that last part, or as in general?
In general, you need to look for a pattern.
All of them is addition,
Mm,
and that I'm not really sure.
all right. All right. So it's a little tricky, right?
Yeah, kind of. Yeah.
All right. Let me see what we can figure out. Again, this is one of the harder questions. So write a relationship between the number of sticks and the number of dots. So in other words, how are these sticks linked to the number of dots? So like, what would I need to do with the dots to get these sticks? That's what we need to do.
The 42, the N,
Say that again.
the figure number, which is 42.
Wait, let me take with time. So we know with this, our main focus is going to be the sticks and the dots. So look at this very carefully. How is the sticks linked to the dots? What are we doing to the dots to get the sticks? That is the question. So let me show you how we're going to tackle this. In the first round, tell me, Alexia, is there a difference between the number of sticks and dots?
No.
No, there's no difference. In this instance, is there a difference between the number of dots and the sticks?
Yeah.
Right. What do you have to do with the number of dots to get the sticks?
Add 1,
You need to add 1. Over here, we added what?
0.
All right. What are you gonna do here to get the number of sticks?
Add 2.
Are you noticing a pattern?
Each one is increasing.
It's increasing, right? But let's dig a little deeper.
One, wait, no, that's not. How's the phrase this? Just I think I know what I want to say, I just don't know how to phrase it.
This mosquito. That mosquito only buzzing by my face. Yeah.
I don't know.
All right. So when the figure number is 1, is there a difference? Yeah or no?
No.
No. So when n is equal to 1, the difference is 0, right?
Yeah.
What would you need to do with 1 to get 0? What,
Huh?
what would I need to do with 1 to get 0?
Nothing.
Now, if you do nothing,
Wait.
what would I-
-1?
right, that would give me 0. When n is equal to 2 now, I'm seeing that the difference is +1. So
Yeah.
doesn't 2 minus 1 give you 1?
Yeah.
Okay, when n is equal to 3, let's see if this pattern holds. When n is equal to 3, it's going to be 3 minus 1. And that's going to be equal to?
2.
Okay. So observe a pattern here. The number of sticks is linked to the number of dots by this relationship you notice here. When n was equal to 1, they were the same. When n was equal to 2, the number of sticks was 1 plus the number of dots. When n was equal to 3, the number of sticks was what?
2.
2 plus d?
The number of steps. Wait, the number of dots?
Yes. So we could summarize this relationship via this. So it's going to be S is equal to n, it's going to be n minus 1 plus d. And let's just check to see if this makes sense. So Alexia, let's do a couple trials to see if it makes sense, right? So Alexia, when n is equal to 1, when n is equal to 1, the number of sticks is going to be equal to 1 minus 1 plus the number of dots. What's the number of dots initially when n is equal to 1?
5.
Okay. What's 1 minus 1?
0.
What's 0 plus 5?
5.
Okay, so does it work when n is equal to 1?
Yep.
Okay, because
Yeah.
when n is equal to 1, I'm getting that the number of sticks is 5. So it does work. Let's try it when n is equal to 2 now. When n is equal to 2, the number of sticks is going to be n minus 1. In this scenario, n is actually 2. So that's going to be 2 minus 1. And what is the number of dots in figure 2?
8.
Right. What is 2 minus 1?
1 and plus 8 will give it 9.
Right. Do we get the correct number of sticks? Check it for me. Do we get the correct number of sticks?
Yeah.
All right, Nikolai, let me verify this again, right? So Nikolai, when n is equal to 3. So Nikolai, look at it for yourself. When n is equal to 3, what is the number of sticks?
13.
What's the number of dots?
11.
Okay, let's see if our formula works. So according to our formula, if we want to find the number of sticks, it's going to be n minus 1 plus d. Could you tell me what the figure number is? What was n? For this, I'm testing this one.
With 3. 3.
So that'll be 3 minus 1. And when n is equal to 3, what is d?
3 minus 1 was what? Oh,
So-
D was 11.
Right. So it's 3 minus 1.
2.
2 plus 11 is?
13.
Does it work?
Yes, sir.
Yeah, it does work. So this was one of the harder questions, right? Because they're asking you to come up with a relationship between the number of sticks and the number of dots for figure n. So like, how is the sticks linked to the dots using n? A bit hard. Does everybody understand it? I feel like a good bit of y'all do understand this one. And it's valid. I understand why you would not understand this one. It's a bit tricky. So if you don't, just let me know, I'll go it over again. Okay, I hear in silence.
No, sir, we good, sir.
All right, well, let me do another question. Let's move on to 2024. All right, so Alexia, if I pull up May 2024, you're gonna handle it like nothing, right? Well, let me do Jan. Let me see what Jan has in store for us. Wait. So this one is a bit different. All right, so in the interest of saving time, I've already drawn the pattern. I want you to look at this and tell me if you're confused by the pattern. If you are confused, just let me know. I'll try to explain it. But it's a visual thing.
I think so. Nah.
Oh, you understand this?
Say doubling in size. Like the first one is the smallest one, then the second one is like it's over that one, but I didn't get the numbers yet. It's like a bigger house. No, the smaller house fit into a bigger house. That is what it's looking like here.
Yeah, you can think of it like that. So I'll explain this one for you guys, right? So Nikolai, you notice we started with one here, then we have three blocks, I mean three circles at the bottom. Yeah? 1, 3, 3, 3. Yeah?
Right.
I'm gonna be seeing now.
Yes, sir.
All right. Then we have one circle there. Then we have 3 here. Then we have 5. So 1, 3, 5, 5, 5. See that pattern?
Yes, sir. It's by odd numbers.
Yeah. And so shape 3 now. Let me erase what I have. Let me erase the hints that I have. Let me figure it out manually. Yeah, so Nikolai, back to this, right? So we have 1 over here. We have 3 circles, 3 circles, 3 circles. Yeah?
Yes, sir.
We have 1 here. We have 3 circles. How many circles we have here?
5.
How much?
5.
Okay. So we have 1 here. How much we have here?
3.
How much here?
5.
Yeah.
And 7.
And then all of them on the
Going
dice.
down.
So then in my other diagram, I'm gonna start off with 1. Then I'm gonna have what? Come on. 1, then
3.
5,
5. 7.
mm-hmm.
Then 9. And then 9 going all the way down.
Right. And how much times? So check out the pattern, right?
6.
Let me
Like
check out the pattern again, right? So this is 3. Then we have that's 5.
4. No, like 5, right? Okay.
And then this went up to wait, this is okay. This is 3. This is 4. This is 5. And so yeah, it'd be 6, right?
Yes, sir.
Yeah. Let's try 9. 9. Okay. So in our final diagram, this is what we need to have. You need to have 1 here, 3 here, 5 here, 7 here, 9 here, and you have 9 6 times. Yeah, so as opposed to adding another block here. Alexia, I wonder if you're confused or if you understand this. Okay, I heard. Okay, I see you on mute.
I understand it, kind of, yeah.
Okay, well, let me fix that. I want you to actually understand the whole thing, not just like kind of. These things are highly visual. So, Alexia, when you look at this, right? We start off with one circle here, seeing that?
Yeah.
And then we have three here, three here, three here.
Mm-hmm.
Then over here, I have one here. I have three here.
Yeah.
I have five, 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 five. A couple things to notice, Alexia. We start off with the one, right? Upper back three,
Yeah.
but this now increased by two. Seeing that?
Mm-hmm.
So
Yeah.
then in the other diagram, you can imagine is 1, 3, 5, then what?
7.
Yes. Now let's pay attention to how much times the same number is being repeated. Over here it's 3 times. Over here it's how much times?
4. So the bottom number is going up by 1.
Yes. So let's verify that, right? How much you see in here now?
5.
Yeah. See in 5. And do we notice the pattern like what? 1, 3, 5, 5, 5. Over here is 1, 3, 5, then 7, 7. You see that?
Mm-hmm.
So let's try to figure out what the other one will be. So we can start off with 1. What next?
3.
What next? Let me spell out close,
5.
right? Right. Mm-hmm.
Then 7. Then 9.
How much times am I going to repeat the 9?
6 times because they added 1.
Yep. You feel like you fully understand it?
Yeah.
Right, Nikolai, like you try Romano. I'll give you a question to do just now. Like, sorry, I didn't call you. Romano, let me know if you understand this.
Yes.
Alright, so Romano. We have 1 here. How much you have here?
3,
Next one?
5,
Next one?
7,
And then I have how much sets are 9?
uh, 6.
Yeah. Hope you understand this. Right? It's a good thing I checked back the diagram because I didn't complete the diagram here. Right. Let's move on. So this question is kind of hard. It's a bit different from the other ones. But it isn't as hard as you think because like they spoon feeding you in a sense. So Alexia, you're gonna help me come up. So I'm just assign rules, right? So Alexia, Sky, and Romano. Well, Romano, you don't have much to do there. Have an easy job, Romano. Right, so Alexia,
Mm-hmm.
we need to figure out a relationship over here. And a hint I could give you is to look at this and see if you see a pattern.
What the number being multiplied by going up by 1.
What do you mean by that?
And so 2 by 1, then 2 by 2, then 2 by 3.
Okay.
Um,
So what do you think the 1, 2, and the 3 represent? Perchance.
the figure number, I think.
Yes. Watch. If you're confused, watch. 1, 2, 3, 1, 2, 3. See now?
Mm-hmm.
Alright. You noticing the figure number anywhere else?
Yeah, in the beginning.
Right? So let's generalize this thing now. So instead of 1, 2, and 3, what am I gonna write here?
Um,
What does 1, 2, and 3 represent?
the figure number, so n.
Right? And
So
consistently adding what to that?
1
Right? So n plus 1. What next?
and plus 1.
You gonna write n plus 1 again?
No, you can't write that.
Nah, yeah. Be careful. So like in the second bracket, whatever is remaining the same, you write it back. What's remaining the same here?
2
Right, so I can write back 2. Mm-hmm.
plus 1
Hmm?
plus 1.
Nah, but if you're getting something, wouldn't just be 2. Watch. You're multiplying 2 by 1 here, then you're multiplying 2 by 2 here, then 2 by 3 here. So what would the 1, 2, and 3 stand for?
The figure number.
Right, so I'm supposed to write 2 what?
2 1 and
2n plus 1. You sure you understand that?
yeah.
Because watch, 1, 2, and 3 changing per accordance with the shape number. So like you can see in it like this is 1, it's 2, it's 3. You seen it, right?
Mm-hmm.
Yeah, sure.
Yeah.
Sure, like 100, like okay, more than 100%.
Yeah, think so, yeah.
Think
Because
so?
it was remaining the same. Because the figure number remaining repeating, and after the twos, which is being multiplied by the figure number, it repeated on each one. It's each 1, 2, and 3, and after the number that being added to the previous figure is also repeated.
Yeah, so anything that's repeated and not changed is a constant. So that remaining the same. Yeah, understand that, right? Like everything that's remaining the same is
Yeah.
constant. It's constant. It never changes. All right.
Yeah.
I feel like you understand that. Good job. Sky, help me with this. I promise, Sky, it's real simple. Promise.
Okay. You know my eyes are not working. Okay. It's not looking real hard.
Nah, it's very simple. It's very simple.
So you could just explain, like, do I
Nah,
know something
I can't.
funny?
I can't do that.
Episode?
You have to figure this out yourself. Guys, and until you think Sky could figure this one out yourself.
Yes.
Stop gaslighting. Stop gaslighting.
Oh, we're not gaslighting it. Real simple. Like Sky, you know there's a pattern
I
here.
was
Tell me if you know there's a pattern here. Somebody put
eh,
it in the chat.
yeah, so somebody said don't overthink it. No, but so I asked it to summarize because I went to the bathroom and Alexia was doing the first one.
Okay, look at what Alexia did. to come up with this?
So n as in the shape number.
Mm-hmm. N is the shape number, yes. God, you can do
So
this.
I don't like how everybody like believe in it, man. Like I feel like my mind.
Nah, you could figure this
Tell
out.
my brain today is not with me. My brain is somewhere else.
It's in the sky.
Somewhere it have to be. Okay. So the shape number plus one.
But like, okay, why did we say the shape number plus one? Why do you think we said shape number plus one? Hmm.
Well, that's a final the number white.
No, but here I'm asking, like, why did we write? Why did we say n plus one? Why did I write back the one? Why didn't I change the one?
Well, in the first one I seen one plus one. One plus one is two. One by two.
No, forget about all that. Like, just look at it. In the first bracket, you're saying 1 plus 1. In the second bracket, what are you saying?
Two plus one and then three plus one.
What do you think the other bracket go say?
4 plus one.
The other one.
5 plus one.
Okay, so generalize that now. What would you write? So when I say generalize it, I mean remove the numbers and use a variable to represent it.
N plus one.
Right, because 1, 2, and 3 is just the what?
The shape numbers.
Great. Let's see, let's figuring it out. And the 1 is the 1 ever changing?
No.
Okay, so if you could see that and figure that out, you should have no problem figuring this one out. You should be able to figure it out.
Okay.
You can
Well,
do this.
you know what's scaring me is the squared. Why is the squared there? It's different. Okay.
You're being too negative, man. You're being too negative. Lock in.
Oh, okay. Is it n plus one squared or no?
Yes, that is
Okay.
literally the answer.
I was literally about to cry. I swear. My brain is not here. Not.
I feel like you're real overthinking things today, boy. But yeah, it's n plus 1 squared.
I'm very emotional. Say I don't know what's going on.
Don't worry, we are supportive and we're here for you. We're here for you. Yeah. Because you notice that 1, 2, 3 that changing and is actually just the shape number. But the one remaining the same, so I had that right back one then. Right back one. Yeah. All right. So Romano,
Hi.
your turn to cook. Right, so Romano, how are we gonna figure this out?
Well, if we look at the number of white counters and our black counters, when we add them, we get the total number of counters. Uh, you know that for the shape number 4, if the pattern for the number of black counters is shape number plus 1 squared, then the next pattern will be 4 plus 1 squared, which will be 5 squared, which is 25. And then we just add 45, 25, which will be 70.
Now, is there any other way you can do that question?
Well, the fact that you asked that question, probably, yeah.
Well, figure it out. That's correct, by the way, but figure it out. You can do this.
Oh, okay.
And if you feel like it's something different and you knows the exact same thing like last time, so like Romano, how you figure out the 52 over here?
Um, yeah, you just substitute, you just, 2 by 23 plus 6.
Okay, got this question.
3 by 4 squared plus 5 by 4 plus 2.
We know if you get any same answer. So 4 squared is 16, that'll be 48, 48 plus 20. That'll be 68, 68 plus 2 is 70.
Yeah.
Yeah. You didn't see that one.
Nah.
But to be fair, I didn't see it your way initially. When you see it, I was like, yeah, that makes sense because it's total number of counters. So everybody thinks differently. That's fine. Does everybody understand how Romano got the total number of counters? Sky, you understand or not?
No, sir.
Okay, I like the honesty. Sky, do we have a formula for total number of counters?
3n squared plus 5n plus 2.
It's a common mom just now. Yeah, say that again.
So,
One
and
second. An emergency probably happened. I don't know. Yeah, sorry about that. Thankfully, there's no emergency. Yeah. Sky, you there?
yes, sir.
Yeah, so Sky. Is there a formula for total number of counters?
3n squared plus 5n plus 2.
And this formula tells us the total number of counters. It tells us the total number of counters if we plug in what? I promise you, it's the exact same thing as the last set of questions. Nothing changed.
The shape number.
Yes. So if I want to find this over here, all I have to do, you tell me. How do I find this?
Hmm.
So again, Sky, do we have a formula for total number of counters?
Yes, sir.
Right, we have a formula. What's our formula?
3n squared plus 5n plus 2.
Right? Do we know what n is for this row?
Yes.
What's n?
420.
Nah.
No.
Remember, n is the shape number.
Oh,
So n will be equal to 4. So if you know n is 4, you just have to plug it in and you get your answer, 70.
okay. I don't know why my mind went
I
by
feel
the
like
book now.
I feel like something going on today. I don't know.
But I don't know. I really don't know. Mirasic, my brain in the sky. I don't know what I'm feeling good.
All
I don't
everything over the place. Things crazy right now. But is our pass and cloud will be fine. Yeah.
Wow. Okay.
No pun intended. No pun intended. But the other thing that he did, Gary, notice it says total number of counters. Total number of counters.
Yes, sir.
What does total mean? Yeah, the word total. What do you think about?
All together.
Yes, all together. So like we have black counter, we have white counters, and we have black counters. So alternatively, you could find the number of black counters by plugging n into the formula for it. So 4 plus 1 squared, 25. And then simply add the total, add the number of counters to find the total. So Gary, you understand this completely?
Yes, sir.
Yeah. Okay, great.
Auntie Shy
Wait,
to talk to you.
wait, give me a second. Yeah, let me continue. So Gary, I want you to help me with this. How am I gonna find the shape number for this row? So I give Gary a kind of hard question there. A little tricky.
Um,
So how am I going to find the shape number?
Question, sir.
Mm-hmm.
Is it 11?
Is it 11?
Yeah,
Yeah, it's 11.
okay. I just did some mental math just now, sir.
That's good. Now, Gary, let's think. Let's think, Gary. Oh God, I see your name and I'm just thinking about Gary from SpongeBob now. All right, so Gary,
yes, sir.
there are two ways you can work this. You want to make your life hard or easy?
Both.
You want to make your life what?
Both.
Both? Okay. Well, Gary, we're trying to figure out the shape number here. Do we have any other information for this rule?
Yeah.
What information we have?
The 144 and the 420.
Right. The 144 is in what column?
The number of black counters.
Right. Do we have a formula that tells us how we could find the number of black counters?
N plus 1 squared.
Right. So n plus 1 squared. So using this formula, tell me, Gary, and if I use this formula, I just had to plug n in and I would get the number of black counters.
Yeah.
You sure you understand that? So like if I want to find the number of black counters, I just plug n in. Yeah?
Yes, sir.
Yeah, sure. If you don't understand that, just talk to me, Tell me if you don't understand that.
Um, how we get 11 again?
11? Okay, don't worry.
Yeah.
I'll share that just now. But Gary, do you understand that if I want to figure out the number of black counters, all I would do is I would just take whatever n is and I'd plug it in into this formula. Yeah?
Yeah.
But do we know what n is over here to make it 144?
No.
Nah, so we could form an equation. So I could say n plus 1 squared is equal to,
144.
right, so now I have to solve for n. I'm trying to figure out what value for n would give me 144. And it's simpler than you think, right? What plus 1 squared would give you 144? Think about your 12 timetables.
12.
Right. So what's 12 squared?
144.
Right. And in the bracket, we have
N plus 1.
So what would n have to be to give you 12 in that bracket?
143.
Nah. Remember, whatever is in this bracket, you're gonna square it. So like,
Right.
and you just tell me that 12 squared is?
Yeah.
What is 12 squared?
144.
Right? 12 squared is 144. And so in this bracket, you have n plus 1 squared. Now, we know that 12 squared is 144, yeah?
Yes, sir.
So what would n have to be to make the bracket 12? So we add in 1 to n.
11.
Yeah, because what is 11 plus 1 squared?
144.
Yeah, because you'd work the brackets first. What's 11 plus 1? It's 11.
12.
Yeah, 12 squared. Now, you could look at it and figure that out. Let me show you the long working now. Now, using the reverse operation, you have n plus 1 squared. If you didn't see it, you'd have to do this. So you want to get rid of the square. So you have to find the square roots on both sides. You understand?
Yeah.
So what is the square root of something squared? All right, Gary, when you cancel off, you just cancel off because the square root and square, they're opposite operations. It's going to cancel off. So if this and this cancels off, what is that going to leave us with?
1 plus 1.
Mm-hmm.
And
What's the square root
add
of
the 12.
12? Yes. Now, notice I did not say plus or minus. A question. Do you think we could have a negative number for the shape number? Palmer Gary, do you think we could have a negative number for the shape number?
No.
Nah, because the shape number will be counting, right? Shape 1. Would you say shape negative 1?
No, no.
No, no, no. So notice, well, when you find the square root, you have two solutions, a positive and a negative solution. But I hope you understand why I did not consider negative 12. Because you can't have a negative shape number. Understand?
Yeah. Yes, sir.
And then you'd want to find for n, so you could take away 1 or move across 1. And you're going to get 12 minus 1, which is 11. You understand?
Yes, sir.
Yeah, sure.
Yes, sir.
All right. Something about you, it's sounding a little unsure. I sensing like a little unsurety.
Yes, sir. I just tired.
Okay, no problem. Right? Nikolai, let me guess. When you look at this, right, it was like, 11 plus 1 is 12. 12 squared, 144. 11 is the answer.
Yeah.
Yeah, give me that.
Sir, I'm telling you, like when you show me how to do this, everything just get real easy with this sort of work. So
Hey, boy. They help you. No, that's one way you can do it, right? If you like yourself, that's how you could do it. If you don't like yourself now, you could potentially use this. Because Nikolai, and we have the total number of counters here and an equation for it.
yes, sir.
Now let me do this quickly, right? So 3n squared plus 5n plus 2, and that'll be equal to 420. If you do it like this, you'll have to solve the quadratic when it's equal to 0. And so you'll have to move across the 420. So if I move across the 420, it's going to be plus 2 minus 420. And since we moved across the 420, there's nothing on the right-hand side. So I'll put equal to 0. So 3n squared plus 5n, and then we have 2 minus 420. Where's 2 minus 420? Do any of you guys know? 2 minus 420? That's minus what?
The 420
418.
or 418.
Minus
But
4.
418, why went higher? Sorry.
Now, to solve this, you would have to use the quadratic formula. I mean, you hate yourself, right? You hate
Oh
yourself.
yeah.
Why?
So I don't hate myself, So
Now let's solve this thing using the quadratic formula, and let's see what we get to. Let's see. One of my answers supposed to be 11. I wonder if this factorizable, boy. Like, let me kill my brain right now. Let me kill my brain. Uh, mm, no, that wouldn't work. So like,
so that is you hating yourself now?
wait a second. I'm thinking. No, that would work. Yeah, yeah, I'll figure it out. And well, this could be positive. And well, yeah, this could be negative. Wait. So, right, one thing we had to do though. Right. And well, positive, negative. Yeah, I figure it out. That's it. So you're gonna put 3n plus 38 is equal to 0. And so n would be equal to minus 38 over 3. But Nikolai, I think that could be correct. You think this correct?
You can have a fraction and then a negative of the square root.
Positive one would say, they're not legal.
Exactly.
So, I mean, so Gary, when I asked you if you hate yourself, that's what I meant by if you hate yourself. Because if you hate yourself, you would use this to solve for n. But I mean, the easiest one to use to solve for n is just this. The 144 and the n plus 1 squared.
That is when you love yourself.
I wouldn't go so far to say that. Yeah. All right, last question for the night. We are finished yet. We need to figure this out. I'm gonna ask Sky to fill out the table, or the last thing in the table. So Sky, help me with this one. Help me fill out this.
Sky, you could do this.
Aim for the sky.
So
Aim.
didn't she say she brain was already in the sky? So it's just she had to go up there now.
That's
Up and above.
You're
She-
so trying to send me there right now.
Infinity and beyond. Wait.
To infinity.
Beyond.
This is Sky right now. This is how Sky feeling right now. Wait. Sky, this is the wait. Take a second. Oh, I don't know why I'm looking. I update my laptop on my iPad and will being dumb
How
now.
the stars looking?
Hmm?
No, I was telling Sky how the stars looking. It's technically night right now.
Yeah. She's wishing upon a star.
You're burning.
All right, so let me not beat around the bush. Sky, tell me what the answer will be. Like, how could I figure that out? It's easier than you think.
Okay, here comes the sun. It's coming back. Okay. Like, everybody else is answering. Good, cool.
Nah, hey, Sky, you could figure this out, watch. Like, Sky, we want to figure out the number of white counters over here.
Okay.
We could do that. Hmm.
I'm gonna make a guess, okay?
Yeah.
Wait, New Year's always 7 Are we going to substitute the shape number into that?
See?
Remember, don't overthink it, eh?
Don't overthink it. You tell me what to write.
11 plus 1 in brackets, and then 2 by 11 plus 1. I
Olive,
don't
Olive, she correct?
know.
Nikolai.
I
Roman,
was gonna say no, but then Laura just messed up she mind, so yeah, it's correct.
Roman, you how evil Nikolai is, boy. You how evil Nikolai is.
Yeah, man.
Nikolai is
Wait,
evil.
no, seriously?
You're correct, you're
That,
correct.
No, correct, but I was gonna say no.
no, you were good.
Just evil. He just evil. But Sky, you see, like this stuff know how to be hard. Like it actually very easy.
So it's my brain that's be bullying me. Like, I don't know why.
You have a Nikolai in your brain or what?
Nikolai was just
I
forming
feel
to give you a
so.
smile
I
there.
feel so. I don't know why.
Hey, Nikolai.
Nikolai, pull out your phone and do a thing, just laugh there.
No, but it's just I wanted to see she reaction now. If she would have
I
overthink it
think I
again.
would have just sat crying.
Way boy Nikolai, you making girls cry now. Way boy
We would
Nikolai.
have seen rain for there.
Oh, way boy. Nah, boy Nikolai boy. He's saying quiet now.
Is he?
He might have
That
a
was kind of really.
All right.
Nah, that was one of my family members. I know me. You know I don't give trouble.
Sure, sure. Right, so I will let so like these is easy 6 marks. Easy 6 marks, but then have like a notice question after for like 2 marks. That shouldn't be for 2 marks, it's like more. Alright, so I'm gonna let Nikolai wrap up this. Nikolai, get us a read for me.
The expression for the total number of counters T equals W plus B in shape S is given by T equals AS squared plus BS plus 2, where A and B are both positive integers by substituting
Wait,
suitable values.
that is
Huh?
integers, eh? That's
Huh?
integers. That's integers.
Yeah, I can't pronounce properly. My bad.
That's okay.
By substituting suitable values of S show that the total number of counters in shape 1 and shape 3 in terms of A and B is represented by the equations A plus B is equal to 8 and 3A plus B is equal to 14 respectively.
Wait, eh? Yeah. So
Sir, I got high mark in English, you know, sir. Just I can't pronounce.
feel like you gotta reevaluate that. I'm joking, I'm joking. All right, let me do this question quickly. So the expression for the total number of counters, right? So as Romano would have told us above, if you want to find total amount of counters, you need to add the white and the black. In shape S is given by, so the expression for the total number of counters, T is equal to W plus B, in shape S is given by T is equal to AS squared, right? AS squared plus BS plus 2. All right, by substituting suitable values for S, show that the total number of counters in shape 1 and shape 3 in terms of A and B is represented by the following equations. Okay.
This is looking like a very nasty question, sir. Not going to lie.
It is always look hard, but it's actually very simple. Like that if it's one thing I like to take away from me is like it is only look complicated, but like you have to understand there is an answer. And if you start thinking the question unsolvable, then it will become unsolvable. You need to be better than that. You need to, even if the question looking crazy, you need to like know there is a solution. Actually, there's a lie. Sometimes in CXC, there's some faulty questions. You really can't. It might be cooked. Might be cooked. Yeah. Don't know what to say. But Nikolai, let me show you how easy this is now. So they say by substituting suitable values for S, show that the total number of counters in shape 1. Okay, so Nikolai, immediately they're talking about shape 1 and what? What else are they talking about?
Shape 3.
Talking about shape 3. Right. So here what, Nikolai? And if we want, and we could look at the table and see the information for shape 1.
Yes, sir.
Okay, let me look at the information for shape 1. In shape 1, what is the number of white counters?
6.
Okay, right. The number of white counters is 6, right? So T would, well, so another W is equal to 6, and this is when S is equal to 1. When S is equal to 1, W is 6. Cool. Where's B?
4.
And as such, what would the total be?
10.
You see, look, you figure that out. Watch how easy this gonna be. Like, again, maths is only look hard. Right, so Nikolai, you with me?
Yes, sir.
Okay, still with me, right? So, T is equal to W plus B. T is equal to W plus B. We know the total is 10. So 10 is equal to, well, yeah, total is 10, right?
Wouldn't it be that the 10 could be substituted into that equation up there?
Yeah,
Okay.
right? So watch this. We have this equation here, T is equal to AS squared plus BS plus 2. We know that the total is 10. We just found the total by using this. Total is 10. So you'd say 10 is equal to, you understand what I'm saying, right? Like, we use this to figure out the total. We use this already. We know that the
Yes,
total,
sir.
no. We know that the total is actually equal to 10. So we're going to use this now in this. And so the total is 10, so I'm going to say 10. I don't know what A is. Do I know what S is?
1.
Right? Okay, do I know what, I don't know what B is. Leave that blank. What is S?
1.
Right? Plus 2. What is A? What is 1 squared?
1.
Where's 1 by A?
A.
B by 1 is?
B.
Right? Plus 2. And your way to look like this. A plus B is E. I mean, you can see the answer already, right?
Yes, sir.
So, like, all you had to do is just move across this 2. That 2 will turn to minus 2. 10 minus 2 is equal to A plus B. And, you're going to end up with 8 is equal to A plus B. Now, if you do a switcheroo, that's going to turn to A plus B is equal to 8. Don't know. So we already get one of the answers. But I just coming out and saying this is not one, it's not a 2-mark question. This is not a 2-mark question. CXC on drugs. Something wrong with CXC. It's not a 2-mark question.
To tell you how things is be tiring. When you told me 1 squared, I was going to say 11.
Oh God. That thing's really bad, yes. I don't know wait till today. I feel like there's something in the air now. Something in the air. Cause Sky, I don't know, something happening. Something out of the sorts.
Sky is in the sky right now.
Yeah, boy. The Sky is smart. So I just Sky, you okay? Like today you seem a little bit like under the weather.
Literally, the weather.
Nikolai, shush,
I
hush.
I not no, I'm not saying any puns. Yeah, like I just saying like you seem under the weather.
Right, right. No, but sir, I really don't know what's going on. I think it's because like how like I just jump up and like just rush to get ready for class.
I think that is it, you
I
know.
think I think my brain's still sleeping. So like I don't know. I don't know.
I think it's how you just get up and just start.
Next class I'll be ready. I'll be ready.
That's good. Let's do this. Let's do this one now. So Sky, you're gonna help me with the next one. It's just simple it is. So Sky, we have two equations here. We have total is equal to white plus black. And then we have this other equation for total, which looks scary, but it's simple. So Sky, we already do shape one, right? So what other shape are they talking about? So they're talking about shape one or what other shape?
Shape tree.
Talking about shape tree. Let's go and look at the rule for shape tree. When you look at the rule for shape tree, what's the total number?
44.
Right. That's extravagant news. So when S is equal to 3, the number of white, well, we already know the total, right? The total is what? 44, right? And so now you're gonna plug that into this. The AS squared plus BS plus 2. You see, but real simple. So like, what was the total?
44. Well,
Do we know what A is? Nah, we don't know what A is.
mm-mm.
So I'm gonna leave that then. I don't know what it is. Do we know what S is?
3.
Right, so I'm gonna write A by 3 squared plus,
Um,
do we know what B is? Common B. Do we know what this B is?
no.
Nah, so we had to leave that blank. Then we have B by S. What's S?
B by 3 plus 2.
Right. 3 squared is 9. That got into 9A. Oh, that looking like 9. So that'll be 9A. And that'll be plus 3B plus 2. Now, Sky, I want to make this look like this. You seen any way we could do that?
So that whole thing, A plus B equals 8 and then the bottom, or just the bottom?
Wait out this.
Oh,
We're-
oh,
Because Sky, we already get this, we already get the A plus B is equal to 8. We have that.
yeah. Okay, that makes sense. So I seen. Okay, yeah. I seen. Well, first of all, it's 3A plus B and then equals to 14, right?
Yes.
I see 9A plus 3B plus 2. So, correct me if I'm wrong, but if it is 3 and 3 is 9, and then 3 by B would be 3. So, wait, hold on. I don't know where I'm going with this. I thought in my brain I was going somewhere.
Yeah, you go in some way. You realize
I'm
that.
going somewhere, but like, wait.
A good piece of advice I could potentially give you is when you look at 3A plus B is equal to 14, the numbers on the left hand side or the right hand side?
The left hand side.
Nah, 3A is part of, if you see in 3A, the 3 is really part of the A, right? That just means you have 3 A's. That's not a number.
So, you're talking about 14.
Yes.
Okay, 14 on the right hand side. Oh, yeah.
Maybe we could like rewrite this. So like,
So like 9A plus 3B plus 2 equals 44.
yes, 9A plus 3B plus 2 is equal to 44. And you know what? Maybe I could move across. If you move across the numbers, what happen there?
So you're moving across.
What's the only number there? On the left hand side. 2. So you're gonna move across 2. Because if you say 9 and 3, that'll be wrong. Because that 9 there really means you have 9 A's, eh? And that 3 really means you have 3 B's.
Yeah.
So you move across at 2. 44
Right.
plus 2 is
44 minus 2, 42.
right. Now, you was going somewhere really good. You was going to space because you was already in the sky.
Right. Right.
So
Okay.
but you're aiming for the stars. Anyways, you have 9, 3, and 42. All of them are what? Starts with D. All of them are the
Divide by 2.
yeah, hey, look, Samir. No, I never hear from Samir, boy. Yeah, sky. All of them are divisible by 3. I think that's where it was going in your head.
Yeah. So you just see the how like my brain wanted to say that, but then my mouth say something else.
I don't know what's going on there. 3 into 9 is what? What's 3 into 9?
3,
Right? 3 into 3, that just a concept scale B. 3
B.
into 42 is 14. I think. Yeah.
So I was kind of going somewhere, but I was lost in the making. Like I was lost. I was lost at the start. I know I was. You see, I know what I was supposed to do.
Wow.
I got.
Sky,
I'm gaslighting myself.
Sky, I can ask you a question.
Yeah.
Oh, no, thank
Yes.
Tell me what our forecast for tomorrow, please.
Me?
you.
No, Sky.
Or Hulk, is she in the sky right now?
No,
Yeah.
because we're kind of, but like, I really don't know. Hmm.
I kind of want rain.
Let me just say, I'm gonna try to be better. So like, they might get some sunny skies answer. You know,
Okay.
hey, no rain like tonight.
It raining by you?
No, I mean like how my brain. I don't know what's going on with me right now. Thunderstorm something. But
Yeah, but watch rainy with some meatballs or something.
yes,
Yeah, rainy
cloudy with that
with a
chance.
cloudy chance of
It's cloudy
meatballs.
chance that I'm yeah, whatever. I didn't even sure.
Cloudy with a chance of
Cloudy with that
Cloud-
meatballs.
chance.
Oh
Yeah,
my
cloudy
god.
with a chance.
Thank
Oh, this is
you.
disappointing.
No,
For
no, no.
No, I
chance,
knew
yeah, oh my god.
We
I knew
just
it was, but it was a while since I haven't seen that show.
we just mentally messed up right now. We just too tired.
Right? Right. Okay.
I gotta watch that movie tomorrow.
I thought you was going to see tonight.
Nah, I'm too tired tonight. I gotta sleep.
But
Um,
well, guys, that's it for class today. Alexia, I don't know Alexia still here, is she? Alexia?
Hi.
Yes, Alexia. So you're feeling better when it comes to pattern recognition now?
Yeah.
Yeah, sure.
Mm-hmm.
You're saying that with like
Yes, 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 yes. Better?
I suppose so, I suppose so. I suppose so.
Right.
You see, like I know what it's like to be utterly confused, so like I could tell when people kinda confused. It's real obvious. I still feel like
I know the time.
I feel like you understand a good bit more than before, but to lock it in, you gotta do homework. You gotta like practice your own. You did practice.
Mm-hmm.
So I give it all you do June 2024 now. Do June 2024 question 7 homework. Yeah. So put any chat, guys. Put June 2024 question 7. Put any chat. June 2024 question 7. I trusted Nikolai to put it in chat. Nikolai, you did send the topics that everybody wanted me to do.
Yes, sir.
Alright, bet. Well, next class, what I suppose I'll do, I'll do one question on this, just one, then we'll move on to functions as you plan. Yeah. I wonder, are you think Christian, I didn't hear Christian in a long time. Are you think Christian is there with us?
So I kind of fall asleep, so
That's okay, that's okay. I mean, I cannot fall asleep too, to be honest. Fall asleep too. Yeah.
and I wake up like 10 minutes ago. So
That is fine. I understand. It is not easy to do maths for like 5 hours straight. It's not easy. I'm proud of you guys for the progress you've made and the discipline you've put into this. Each and every one of you all deserve a one. Pass CSEC maths and done. You know? Well, I'm gonna go eat some food and thing. Have a good night, guys. Take care.
Good night. Hope you all feel better.
Good night. Bye.